Welcome to Localhost Lab, and today we'll do a quick brush up of OOPS in Java. So, what is OOPS? OOPS stands for Object Oriented Programming. It is a programming paradigm, a model, a framework based on the concepts of objects, behaviors, and datas. It focuses on designing software that closely represent real world entities. So, it is used to improve code reusability, enhances maintainability and scalability, makes program easier to understand and manage, closely models real world entities. So what is OOPS? OOPS is a programming framework. So there are a lot of programming languages that follows OOPS. Java is one of them. Now when we are designing softwares, we have to represent real world entities. So using this framework, using this paradigm, it becomes very easy to do so. Also, it helps us with code reusability. Now, when you are building softwares, there's a very high chance that a lot of code is shared, a lot of logic is shared. So instead of writing it again and again, you can reuse the common code. And also, softwares contains large number of codes, lines of codes, and maintaining them would is going to be a very big challenge. You have to think about scaling your software, you have to think about how you will be maintaining your software. So following such a paradigm, it helps in maintaining and scaling our softwares. And also it makes easier for developers and engineers, software engineers, to understand. So we'll see, but before that, let's have a quick idea of a quick brush up of what is a class and what are objects. So class is basically like a prototype from which you can create objects. It is like a blueprint. It is an user defined blueprint. A class can a class can be public or have default access, okay, and it see there are certain conventions that you have to follow while creating a class in Java. You can read more about it. So it should always begin with an initial letter, okay, like if your class name is car, the C should be capital. Same for Mercedes, Audi, BMW. And the body, it can each class contains a body, we'll see. And once you instantiate a class, it you will create its object. So it is a basic unit of OOPS that represents real life entities. And you can invoke the methods, you can invoke their members, okay. So very basic. Now we'll see the four main pillars of OOPS. So what are the four main pillars of OOPS? The first one is abstraction, inheritance, encapsulation, and polymorphism. So what is abstraction? So abstraction is basically hiding the implementation details and only showing the essential features of an object. So it rather helps on focusing only what an object does rather than how it does it. We are not concerned with how the internal working is, we are only concerned with what that particular object does. Like, suppose you are using an ATM and we don't know how it works internally. We only know that if we enter the pin, there's a keypad, there's a accept button, cancel button. If you insert your pin, insert your card, and then insert your pin and click on the accept button, you'll get cash. You don't know how it is working internally, and also you're not even concerned, right? Similarly, like coffee machine, we don't know its internal mechanism. We only know that there are few buttons. If we press one, we can get an espresso, we can get an cappuccino. So this is what abstraction is. Now, how it is achieved in Java? Through abstract classes or interfaces. Interfaces can provide 100% abstraction, while abstract classes provide partial abstraction. So, abstract classes can have concrete implementations as well. Okay, now we'll see with a code snippet so that you'll understand better. Now, the next is we'll see. For now, let's just discuss the theory and eventually we'll look at the code snippets. Next is encapsulation. It is basically wrapping up of data and methods into a single unit, usually inside a class. And you will restrict direct access to the data. It acts as a protective shield. So a class can have methods and members, data members, and you can use access modifiers. So there are different access modifiers like private, public, protected, and you don't want to expose the data members of a particular class to the outside world. Then what you're doing is you're basically encapsulating, wrapping up the data inside a single unit. When I say single unit, here I mean the class. Okay. Now there's this another concept called association. It basically defines relationship between two or more classes that are somehow connected to each other. So basically association is nothing but relationship between objects. Okay, so there are different types of association. We'll quickly go through it. So the first one is the weak association or aggregation. So it has a relationship where one class contains a reference to another class. You are creating an object of another class into some other class, and then you are invoking its methods. That is a weak association. Then we have something called a strong association, where one class owns another class. So the thing is key, like a parent child relationship, a child object cannot exist without the parent, right? Now the next is inheritance. So inheritance, it is an oops concept which enables code reusability, and it represents a is a relationship. So if you are inheriting, so there has to be a parent, there has to be a child. You are inheriting something. You can only inherit from your parent, right? That is why it is a this represents an is a relationship. Like we have an animal class, and dog, cat, cow all are child of animals, right? Dog, cat, cow can be derived from animal based class. So inheritance in Java, so there's single, multiple, and hybrid. Single में multi-level and hierarchical. So a subclass inherits from one superclass. Multi-level is a class is derived from another derived class, forming a chain. Then hierarchical inheritance, multiple subclasses inherits from a single superclass. Multiple inheritance. So Java supports multiple inheritance only through interfaces. It does not support multiple inheritance using classes. So this is a very important point that you should make a note of. Then hybrid, a combination of two or more. So in Java you can only extend one class, but you can implement multiple interfaces. Then polymorphism. So polymorphism literally means many forms, where a single entity can behave differently in different situations. Okay, so there are two types of polymorphism: compile time and runtime. As the name suggests, while compiling the polymorphism that happens is compile time, whereas during runtime it's runtime polymorphism. So there are so compile time is method overloading and runtime is method overriding. So what is method overloading and method overriding, we'll see in code snippet. I hope the theory is clear. Let's move to code snippet. So first let's see abstraction. Now here you see I have an abstract class called vehicle. It has an abstract method who whichever child class will extend this vehicle class, they have to provide the implementation for this, and then this vehicle itself provides implementation for stop. Now this car, it is extending vehicle, and it is providing implementation for this. Now the same thing can be achieved through interface as well. So this is a very classic example of abstraction. Okay. Next is encapsulation, wrapping up of data into a single unit. Now here I have a class called account, and then it contains a data member called as balance. It is private. Now how an someone outside of this class can access this data member? Through getters and setters. These are public methods. They can't directly access this data member of account. Then we have polymorphism. So here you see I have two methods with same name in a single class, but their signature is different. The return type of this method, both the name of the methods are add, but the return type is different. We can also have different arguments. Okay, so now suppose you can create a method like this also. The argument is different, right? Here also, like suppose if I copy this, so these are examples of method overloading. This is a compile time polymorphism. So at compile time only there is a clear distinction. Now suppose if I have to call the method, suppose if I pass only one int, I'll create its object, and let's say I create its object. Now see, I am getting all these options, right? So during compile time only there's a clear distinction, right? Now we'll see runtime polymorphism, method overriding. Now suppose I have a class animal. Now this dog is extending this animal, and dog is overriding. So this is child, right? And this is parent. So dog is overriding this method of parent. See, it is annotated with override and providing its own implementation. Now here when I'm creating an object of this, I'm creating an object of dog. It will satisfy, right? Because it is extending. Now when I call this a dot sound, it will call this, right? It is because it is an object of dog. So this is runtime polymorphism. At runtime it is decided which method to be called, either this or this. Then we have inheritance. Animal, dog extends animal and it provides its own. So basically, we are reusing. See, all animals eat, so dog will also eat, right? So we are reusing this piece of code. So this is a quick brush up of OOPS. You can always read more about it, and if you have any doubts, you can ask in the comments. Thank you for watching.